Dear friends, we are coming to you on the next topic in data structure. This is polynomial representation using linked list. So a little bit of mathematics. We have studied what's a polynomial. So let's imagine a polynomial P1. There are two polynomials written here. For example, polynomial P1, which is of degree 4. So polynomial consists of coefficient and power. So 2x to the power 4 plus 5x to the power 2 plus 3x plus 1 equal to 0, and a second polynomial. Now when you look at the polynomial, okay, let me call this to represent each of this as a term. Okay. Now if I look at a polynomial, let's imagine this particular term. Each has a coefficient and a power, a coefficient, power, a coefficient and a power, coefficient, power. So let's take this polynomial. The coefficient here is 2, power is 4. Here coefficient 3, power is of course 1. Here coefficient is 1, power is 0. So let me take a simple example of this particular term, okay, that is 4x to the power cube, and let's see how it can be represented and apply it to the entire polynomial. So I'm going to take this particular term 4x to the power 3. So if I look at a term, particular term 4x to the power 3, it has a coefficient and a power, that is 3. So can I define a structure in which a node of a linked list which will consist of the coefficient value, power and link to the next. So I have defined a structure here. Okay, I call it term. Of course, when you do the practical, you can put it as node, but be consistent both ways, don't make mistakes. And let's imagine a term. Then I'm going to declare it as I have a coefficient, I have a power. Of course, I have used C here in order to reduce the writing word. You can use C internally. When you explain the theory part, explain coefficient, power. Internally in the practical, use the smaller words so that your programming typing is lesser. So I have a C, which stands for coefficient, this stands for power, this connects to the next node. So if I represent this particular polynomial using this representation, so I will get a linked list of 1, 2, 3, 4 nodes, and each node having coefficient and its power and a pointer to the next. So for example, in this case, if I represent here, I will have a coefficient 2, 5 and linking to the next node. Next would be 5, power 2 and linking to the next. Next would be 3. Of course, enter this power 2 will be 1. And next, when you go to the last term here, it's also important to enter the coefficient and also the power. Coefficient is 1, of course. The power is 0. That has to be entered for practical programming. So that will be the representation. If I look at the next polynomial, for example, here there is a negative term, minus 3x. Okay, so in this case, the coefficient would be minus 3 and the power, of course, would be 1. So the coefficient is minus value, enter it as minus 3, so it will. So finally, when I print this polynomial, let us say, when I print the first polynomial, I will get 4 terms or 4 nodes, and each node, of course, as a programmer, you are limited by the superscripts, so you can use such a representation. Coefficient, you have it, then put an x, then use a cap or the exponential symbol and put the power, that is 4 plus 5x plus 2. So this is a possible representation. When there is a minus value, of course it will come as plus minus, that can be represented as it is. So this is the first part of representing a polynomial, a possible theory question, how a polynomial represented using linked list. So take a polynomial, explain this part, draw a particular node, then explain the structure required. Then I would also prefer that you represent the entire polynomial as a linked list. So for example, here I would prefer that you perform this operation of 3 nodes, for example 2 to the power 4, then connect to the next node, and so you will have 4 nodes. If you can draw up 5 and 3 and connect to the next, and drop all the notes, so that will make it explanation clear and to the point. Thank you. The next we will see how polynomials are to be added. Thank you.